So we are going to be using the t-distribution. In other words, we're not going to know sigma, we would know the standard deviation S, or sample standard deviation. And let's get right to it. Here's an example. So for those that succeed in pre-calculus, has there been a long break since their last math class? So this information came from my students that took pre-calculus from me. And by succeed, I'm saying they got an A or a B in the class. And the number of semesters since their last math class was less than 1. So in other words, it was either a 0 or 1 semester break without math, and then they went on to get an A or a B in pre-calculus. So I interviewed the students. There were 40 of them that got either an A or a B. The average number of semesters break between math classes, you can see, is 0.72, and here's the standard deviation. So then the claim is that it's less than 1. H1 is going to stay the same, the alternate hypothesis. That implies it's a left-tailed test. The H sub O always has equals no matter what anything else has. And in the question, it doesn't say use 98% or use 97%. So whenever it doesn't say, as a default, we use 95%. Thus, alpha equals a 0.05. So then I draw a little picture like this. I make it a left-tailed test, 0.05 in the left tail, degrees of freedom is n minus 1, and then I need table A3. There it is. Sort of surprised me. So it's going to be one tail, so I need to be using this part up here. One tail with 0.05 means I use this column. And then go down to degrees of freedom is 39, and they happen to have it. So that means that it's going to be a 1.685 for the critical value. And because it's left tail, it's negative 1.685. Then, hachoo. Then, there it is. I'm going to use the calculator. So go to Stat, move over to Tests, and this is a t-test. Type in the data. So right here is the number from H sub O. There's our mean and standard deviation with 40 people. And it's a left-tailed test, so this comes from H1. And then when you calculate, it says the test statistic is negative 2.429. So this negative 2.429, the test statistic, lands farther to the left than the critical value. That means that we say reject H sub O. So that means we're just saying, does it equal 1? No, it doesn't equal 1. And because this landed to the left, that means this, which said it was going to be less than 1, is true. So the claim is true. In order to be an A or B student, most likely they did skip less than 1 semester of math. All right, on to another one. So movies that are rated PG-13, compare those with movies that are rated R. And so are the PG-13 movies, or are they longer than those, are the PG-13 or the R? So the more adult or older people movies, are they longer than the kid movies? There, I could finally say it. So here's the information for the kid movies. It's 118.9. And now test the claim that the PG or the R are going to be longer or greater than that. So I sampled n equals 19 films, and I found that they lasted 141.3 with a standard deviation of 28.9. So the claim is that this sample data, which was only 19 films, that the mean will be bigger than it was for the G and PG movies, 118.9. So the claim is that they last longer than the 118.9. H1 is also going to point to the right, so it's a right-tailed test. H sub O always has equals, and as I said in the last one, as a default, we're using 95% level of confidence. So alpha equals 0.05. Then I just like to write down my sample information, have it all organized here. It's a right-tailed test. Degrees of freedom would be 18 from n minus 1. And then we need table A3. So this is going to be, again, 0.05 and one tail. This time go down to degrees of freedom is 18, so that would be right here, 1.734. All right. Okay, go away. Thank you. Next, use the calculator again, the t-test. Type in the statistics. So this 118.9 goes right here from the claim. And then the mean and the standard deviation, sample size of 19. This one is a right-tailed test. And the test statistic turns out to be a 3.379. So a 3.379 definitely does go past the 1.734. So that means reject H sub O. So that means that they are not equal to the 118.9. And because this landed to the right, that indicates greater than. So the claim is true. So the movies that are for the older people actually last longer than movies for the younger people. Which sort of makes sense to me because kids don't usually want to sit through 3-hour movies. All right, then confidence intervals. Don't forget about confidence intervals from chapter 7. So let's go back to that example with the movies. Here's the sample data. 19 is the sample size. Here's X bar and here's S. And then I'm going to make the confidence interval. So it's going to be a T interval. Type in the data. And it says that so the movies for the older people, they last anywhere from 127 to 155. And for the kids' movies, it was a 118. So does a 118 land within this interval? And it says no. So this interval, all of the numbers are bigger than it was for the kids' movies. So this sort of backs up the last test that we just did. Okay, so that's it. Have fun.